Hello everyone, in this video I am going to demonstrate a 3-stage audio amplifier. As you can see, I have wired my audio amplifier on a breadboard. You can see the circuit looks little messy because of the wires running from the stages to stages. You can see here basically this amplifier consists of 3 stages. This is the first stage, this is the second stage, and this is the third stage. So the signal is amplified on the first stage, fed to the second stage, and from the second stage it is amplified and fed to the third stage. So like this, we are having a gain on the first stage, input divided by output, there is a gain. So from here to here there is a gain, from here to here there is a gain. So like this, the amplifier is finally amplifying the audio signal. This is basically a small signal amplifier. So I am connecting this amplifier to the cell phone. You can see this is the cell phone jack and it is connected to the cell phone. And the first stage is amplifying and feeding the output to the second stage. The second stage is amplifying and feeding the output to the third stage. And from the third stage I am getting the output to the speaker. So these are the oscilloscope probes for the measurements. So let us look into the circuit diagram first, then I will show the oscilloscope responses with the music file. So as you can see, this is the circuit diagram. This is the audio input. Here is the first coupling capacitor. This is the first stage. This is a voltage divider bias network. You can see these are the two resistors at the input. So this network is called, this configuration is called voltage divider bias configuration. The output of this stage is coupled with a coupling capacitor and it is fed to the second stage. The second stage is having similar voltage divider bias configuration. The output of the second stage is fed to the third stage. You can see there is a coupling capacitor in between. Finally, the output of the third stage is fed to this speaker. So this is the stage 1, this is the stage 2, and this is the stage 3. So like this, we are amplifying. We are having a voltage gain here, we are having another voltage gain here, and we are having another voltage gain here. So let us look into the oscilloscope performance with the audio file. So now I am going to play the audio file. So I am playing this audio file. You can hear the sound on the speaker. This is the far view. So if I close the file, if I stop it, there is no sound. Let me play it. So now I am going to show the oscilloscope results. You can see this is the oscilloscope output. This top pen is the microphone input from the cell phone, and this is the amplified output waveform. If we look into the results here, if we look into the data, we can see here I am having an input of 34 millivolts. This is the input, and I am having around 3.5 volts output at the peak-to-peak output at the output. You can see, so this is the result. You can see from 34 millivolts, from 13 millivolts we are amplifying to nearly 3.5 to 4 volts. So this is how the amplifier works. So this is the circuit diagram, and here the amplifier is playing. One important thing I forgot to explain is there is a choke here. This choke is used for filtering the high frequency components from the power supply. So this choke is important in any amplifiers. These kind of chokes must be used. Thanks a lot. Thanks for watching.